All right. Hello, guys. It is good to see you right now. I am about ready for us to go through our questions. I just posted it, so I know some people are still signing on, which is totally fine. A couple things. Thank you for everyone who came after school, including people who were only there part of the time. You guys, between my students and students from other teachers, we had over 75 kids stay after school. Now, of course, we did have some people make some maybe not so great choices when it came to sharing food. But by and large, y'all were so awesome, and I thank you for that. I do want to say that hello. Hey, Brianna. I do want to say that if you didn't make it, it's all right. I'm going to go over stuff today. Please check Google Classroom. This document right here on the right, I just put up in Google Classroom. I did make copies for everyone. There's a wooden box outside my door. So tomorrow morning during 5th period, I will put this double-sided document in that box. Make sure you get it. We're going to keep referencing it throughout tonight. If there is a set of information that I truly wish you could memorize and know forever and ever and ever, it would be the information in this document. Now, hey, Jazz, good to see you again. Now, granted, there are things in this document that I can't guarantee it's going to be on the test. And also, there's definitely things on the test that are not in this document. I can't put a whole year's worth of stuff on 2 pages. But I would say if you really understood this information, you would be guaranteed passing because these are like the main concepts. And so that's why when it comes to the EOC, these are the main concepts. I'll create another one that's a little bit more in depth for the district assessment because this page covers the high level stuff for 1st and 2nd semester. So I'm going to be working on one that has the high level stuff just for 2nd semester for your DA. Okay, so let's go ahead and get started. So we're going to do a quick couple things back to basics, which you should already pretty much know, but if we need to get into there, we can. As a reminder, hey, Lexi. As a reminder, thanks for your help today, sweetie. As a reminder, I have 2 of these open. That's not needed. Let's get rid of one of them. As a reminder, anytime that you see these parentheses, we need to remember to do distribution. So really when it comes to doing multi-step equations, you are going to distribute. So -3 times x, -3 times -6, that's what rocks us the positive. When we have this end parentheses here, that's when that multiplication stops. So we're going to go here. Now I've got my 4 times x and my 4 times 1, which gives me that information there. I'm not going to keep solving that. Again, I'm using the mouse. Wake up. So here, perfect example, -3 times +4 is -12x. And -3 times +3 is, -9. And then I stop because of that parenthesis. So I pick it up again. And then equals 43, and I would solve. I'm not going to take the time to solve. The main thing is when you have distribution, please continue to distribute. Okay, don't just be like, I only did one number. Do all the numbers inside of the parentheses. Here with proportions, we do talk a little bit about proportionals here, specifically sides, proportional, angles, the same. And I have it up here underneath dilations. But the main thing is you want to make sure your labels match. So inches would be on top, feet on the bottom. Inches on the top, we're looking for feet on the bottom. I talked to you about new over old, and that is like the new dilation, the new shape, the new length over the old. Speaking of that, we're going to jump right down here. Okay, I know I'm going fast because I'm going to trust you're going to also watch this tomorrow night. Here we have proportion models. All similar circles are congruent. So if we look here, this is what I'm talking about. Hey, Jalen, good to see you today. Right here, we're talking about all circles are similar. And not only are all circles similar, we know that the ratio of the diameter to the circumference is the same. Anytime you see ratio, so ratio is the same. The other time is here, see how it says what transformation occurred? I guarantee you're going to see one of these on your test. Now, I can't truly guarantee you that, but this is one of the core beliefs of geometry. So I would fully expect you would see this on your test. Whenever you are moving circles or you are doing some kind of dilation with circles, most often two things are happening. The first, look at over here on this paper. Cordelia, good to see you again. Is translating the center. And the second thing is dilating the radius. Those are the two things that happen. So if we look here, I already wrote, we translated 6 right and 2 down, but just to show you, here's our A, here's our B, that's where we're going. 1, 2, 3, 4, 5, 6 over 2 down. You also could have written it like this with the 6, -2. Okay. Now, on top of that, we look at two things: translate the center, dilate the radius. So we just translated the center. Now it's time to dilate the radius. If we go here, we see that our radius on this one is 2. We see our radius on this one is 3. Okay. Now, I told you that when we do the radius, we do the new radius divided by the old radius. So our new radius is 3, our old radius is 2. So this is our scale factor. So what transformation occurred? A transformation of 6 units to the right, 2 units down, and a dilation of 3 halves. Okay. So again, this comes from this document. If you were one of the awesome 70-some people who stayed after school, you already got it. If not, you can get it during class tomorrow or pick it up outside my classroom. But that is a core principle that you need to know. Okay. Rounding decimals, just as a really quick review right here. You will possibly have to round decimals. When we do rounding, we are looking for whatever number. So here it says the thousandth. So we would look for the thousandth place, tenths, hundredths, thousandths. We look at the number next to it. In this case, at number 0. So this would just be 51.048. Nothing changes with the 8. In this case, it says thousandths. We look at the number next to it. It's a 7. Because that 7 is higher than 5, we move that 8 into a 9, change everything else to zeros, and essentially drop them. Okay. Next, you need to remember how to reduce fractions. That's something that you should have learned in elementary school. It doesn't matter how you do the reducing. You can start small. So like here we did divided by 2, but then we just have to realize that we can divide the top and bottom by 2 again, and that we could divide the top and bottom by 2 again until you can't divide anymore. So don't feel like you have to think of what's the greatest common factor. Just start with 2, keep going, keep going. Trick, use your calculator. If I say something here and I get 24 divided by 40 on my calculator, that tells me 0.6. So then I would just see which of these ones equals 0.6 and go from there. Okay, next one. Okay, I know I'm going quick because I'm trusting y'all are going to watch these later, and we got like 100 slides to go over. So now we're going to look at Unit 1 transformation. So if you are home, hopefully you have your EOC notebook. Ooh, Bree, I think I have your EOC notebook at school. But if you have your EOC notebook, you should be following along. So I'm looking at Unit 1 transformations. A core concept with Unit 1 transformations is this, switching back over to this slide, is rigid motion. When you have rigid motion, we are talking about shapes that they are congruent and similar. Specifically speaking, the shape has the same size, area, lengths, angles, everything is the same. There's 3 that have congruent and similar, 3 that are examples of rigid motion. Okay. Yeah, I thought so. You can come get it in the morning. I think I see you tomorrow anyway, but like you should have grabbed it over the weekend, but we're good. We're good. You're good. You're here watching, so we're good. See, you're here watching, so you're all set. Here we go. Translation. Anyway, translation is when we slide. So like right here, I'm Miss Erig. If I slide my chair, I'm still Miss Erig. Okay. My size doesn't change. I'm still congruent. My curls are still the same. My nose is still the same. Everything's the same. I rotate. Same thing happens. Still Miss Erig, completely congruent. Okay. If I flipped, like right now, you're actually seeing a reflection of what I'm doing. So that same thing, size is the same. Rigid motion is congruent and similar. If something is congruent, is guaranteed similar. Always, always. Okay, so now we talked about these things on the very important list. A couple things to remember when it comes to this, okay? Whenever you are doing reflections and those reflections happen to be over the x-axis, you are going to count full boxes. So if I start here, I'm counting how many full boxes to the line, and then I keep counting that number to the new dot. Here, there's 2 full boxes, so 2 full boxes this way. That's different than what's down here. Down here, I'm reflecting over y equals negative x. I'm reflecting over a slanted line. So because it's a slanted line, I'm not counting full boxes. I don't go this way and go 3 and then 3 more. That's wrong. What I do is I count angled boxes. If your line is angled, then you're reflecting over an angled one. So here's 1.5, here's 1.5. Here's 2.5, here's 2.5, here's a half, here's a half. That's the whole premise. If your original ones are up and down, then you're reflecting and making right angles. If your original one's there, look at, these are all right angles. The reflections are caused by right angles. So if the line is diagonal, you have to cross diagonally. The line is straight up and down, you cross flipping it over. Yeah. I kind of don't want to hit the trash can because I want to keep this. So far we've talked about all those things. Let's keep going. Okay. Rotations and translations. When it comes to rotations, I recommend holding a piece of paper up to the screen, tracing the shape, and then turning it just so you can help yourself visualize how it goes. Unless it says counterclockwise, you are always going to be turning clockwise. Clockwise, coincidentally, is that way. Okay. So unless they say a 90 degrees counterclockwise, expect that it's clockwise. Okay. Typically speaking, you'll only see rotations of 90 degrees, 180 degrees, and 270. And it'll help you. Yes, you could memorize this. The main thing to do is hold up that sheet of paper, trace the shape on the screen, and then turn that paper while you're looking at the screen to see how it looks. Translations is the easiest. We're really hoping that we get ourselves some translation questions. All you do is you add. That's it. Add or subtract. How many left? How many up or down? That's it. That's the only thing. In this case, how many right? How many up? In this case, it was how many left? How many down? You do want to pay attention to what's your first shape and what's your second shape. That does matter. That is important. Okay. We're just chugging away. I guess when I've taught this as many times as I've taught it, I can go quick. Okay, next to here. Here's an example of that reflection piece. Okay, this line is slanted, so I know I'm counting slants going down. So here's my first one. This is 1.5. Here's my next one, and then that's basically my box. Okay, I'm going quickly because I have done this in class and you've seen the video. Here's another one. This point is just on the line. Nothing happens. It stays on the line. This line is slanted, so I'm counting diagonal boxes. 1 diagonal box, 1 point here. That stays, so I know I have a 2, 1, 2, 3, 4, so I have a 2 by 4. You also could have done it like this. You could have counted 2, got your point here, counted 3, got your point there. Either way, that's totally fine. Okay. The main thing to remember is if you're reflecting over a line that's horizontal or parallel, you're counting whole boxes. Awesome. Good to hear, Jalen. If you are doing reflecting over a diagonal, you have to move diagonally. Okay. Keep going. Keep going. Dilations. 2 things to know about dilations. Over here, we know that all sides are similar. This is a core thing. Dilation has similarity. Oh, yeah, I did say similar. Dilation is similarity. When it comes to similarity, it does not mean congruent. Now, sometimes there are things that are similar and also congruent, but that doesn't mean that it's always going to be congruent. Sometimes, if something is dilated, it is similar. It is not congruent. No, because there's no really way, Cordelia, that I can tell if someone's watching the whole time. So that's why I'm going to do the extra credit if the questions got done. Unless someone can come up with a better plan, I'll be more than happy to take it. Next, speaking, I've got dilations. They are not rigid motions. And the main thing to remember is when you have dilations, the sides are proportional and those angles are the same. Now down here, we've got, hey, Jahir, good emailing with you today. Here for center of dilation, all you're doing is you're connecting the dots. That was really big. Here, D connects to D, and I keep drawing my line. A connects to A, I keep drawing my line. Wherever they intersect, that's my center of dilation. That's what this is down here. Center of dilation, you connect your A and A primes, and wherever they intersect, that is your point of dilation. Okay? So far, so good. Next. Okay, let's take a look at some things. Which transformation has a greater area? I've been showing you this one because I'm really hoping this is a question that you're going to end up seeing on your test. Here it says greater. Because it says greater, I know that it's got to get bigger. So I often used 100 as an example. Let's say you had $100. If you do 100 by times 0.25, that would be 25 bucks. If you did 100 times 0.5 using your calculator, you would get 50. 100 times 1 is 100. 100 times 2 is 200. That's why we know it's choice D, as in David, D. Okay. Here comes our next one. Okay. You guys are going to be so good for this test because you're working so hard. Here's another one of the dilations things. As a reminder, remember, anytime that we have circles, we know the ratio of the diameter to the circumference is the same. You also could see the ratio of the radii because the radii technically it'll be the diameter, but most times you see that. So really we don't have to really read anything else. The ratio to the circumference is the same. All circles are similar. So all circles have the same, grow bigger and smaller by the same ratio. It's not like half the circle gets bigger. It's not like you would have a circle here and then you end with the circle that looks something like that, which just looks like, I don't know, Ziggy. But anyway, you don't do that. If it starts small, the whole thing gets big or the whole thing gets teeny. You don't have one part that's really huge and the next part that's really small. Okay, composition of transformations. I don't know if you're going to see this. I really haven't seen too many things that use this little symbol here, which means do this one first, then that one. Probably next year's kids, frankly, I'm not going to make them write down because I didn't see anything like this, but in the review book. But nonetheless, that's there. Okay, you will see compositions of transformations. Here's an example right here. It says, which sequence of transformation maps AB into RST? Here's the thing. If I take this lovely pen and this pen, look, it lights up, isn't it? Oh, this is not my light up. It does. See, there's my light up pen. So if I have my light up pen, if I have it just like this to represent the C on my triangle, if I moved it and I rotated it, do you see how the point would be turned? Now it's pointing up. Now it's pointing to the right. If I rotate again, it's the point of the triangle would be pointing down or pointing to the left. Because in the picture, both triangles have the point facing up, I know that there was no rotation because the point stayed up. So I know anything that says rotation can be crossed off. So right away, I'm going to cross off C and D because there's no way it could be C or D because C and D mentions rotation. So that gets crossed off. So now I'm left with A and B. Both A and B says there's a reflection over x equals -1. So I'm going to draw -1. And again, if you were taking this test, you would hold up your piece of paper onto the screen. You would trace the graph. You would trace the triangle. You would put the paper down. You would do the reflection. You would hold the paper back up again. And that's how you would do it. You're going to go back and forth between the paper and the screen. Okay. Now, please don't turn and show someone else your work. Like, don't be silly, but do your best. Okay. So here we know there's a reflection. So I'm going to go 2 this way. So that means 1, 2 this way. Here's my 1 point. Here's my other point. Like this, it's 2 wide. So it would look something like that. Okay. Now the real thing it's asking me, so I don't even need to pay attention to these two because it already kind of told it to me. They're both the same. Now I'm just looking, did it go down 1 or did it go down 5? Just pick a point and count. 1, 2, 3, 4, 5. It went down 5. So it's choice B. Okay. Now we're going to talk about rotational symmetry. Rotational symmetry I have for you right here. Okay. On your sheet. This is one of those core concepts that I really want you to know, rotational symmetry. Rotational symmetry works if you have a regular polygon, meaning all the sides are the same. If you have a parallelogram, like one of the questions we're going to see today, a parallelogram doesn't have all the same sides. Some sides are bigger than other sides. A rhombus has all the same sides, but not necessarily a parallelogram. So it wouldn't work. This way wouldn't work. A rectangle, all the sides aren't always the same. If it's a square, they're the same, but if it's a rectangle, it's not. So this will not always work. This will only work if it looks like the picture here, where all the sides have the same measure. So first step is you're going to take 360 and then you're going to divide by the number of sides. So here I have 360 degrees. And when I divide by the number of sides, in this case, I divide by 3. So I get 120. Okay. Then I multiply that number by 1, 2, 3. So for example, 120 times 1 is 120. Times 2 is 240. Times 3 is 360. See how I hit 360? There's 360 degrees. I don't count it. So these are my two answers. Down here, it's the same idea. I have my 360. I'm going to divide that by 1, 2, 3, 4, 5. Hey, Sammy. So 360 divided by 5, that's going to give me my 72 degrees. Now, here's what happens. I'm going to erase all this stuff so I can scroll up and you can see the answers. Just because you get that 72 or whatever the number is when you get a question like this, and I bet you you're going to get a question like this. This is a core concept in geometry, FYI. But when you get something like this, let me go back to my 360 divided by 5 to get 72. We see 72 is not one of those answers. So that's why we're going to go back over here and we're going to multiply that 72 by 1, 2, 3, etc. In order to until we get what we are looking for. So we've got 72 times 1 equals 72. 72 times 2 equals 144, which is the answer. 72 times 3 would be 216, I think. 72 times 4, and then 72 times 5. Or times, hold on, that's 3, that's 4. And then 72 times 5 would give us our 360, which we don't count. Okay, so that's why it's D. So don't get caught up. It most likely will not be your perfect little pretty answer. You will most likely have to multiply by 1, 2, 3, or 4, or 5, depending on however, to get the answer that's here. Okay. Next. P.S. If it says maps to itself, almost always you're going to use rotational symmetry. There's definitely, I saw one question, there was the parallelogram question that you didn't do it, but that does happen. So Sammy mentioned eating only one pizza. So for those of you who did not stay after school, we had a little bit of drama. I knew people were going to go, but I left the room to go get something. And when I came back, kids went up for seconds and thirds of pizza and they were kind of greedy. So I appreciate that. But that's where that comment came from. All right, let's keep going. Oh, here's the parallelogram question I said. Even though it says maps to itself, it's a trick question because the sides aren't the same. So we're not going to use rotational symmetry. Okay, so here we go. We've got a reflection over x equals 2. Well, here's x equals 2. So if I have a reflection over that, this point would be here. So this would be my new shape, would be like this. And that new shape doesn't go on top of the old shape. So it's not going to be that one. Okay. Then we're going to see, so it's not going to be x equals 2. Y equals 2 would give us the same thing. So it's not going to be y equals 2. So now we're really looking at the rotation. This is when you're going to hold the paper up, trace the shape, and turn the paper against your screen. When you do that, you would see that if you were doing this problem right here and you were doing the rotation, 90 degrees would put that line here. It would end up looking like this. No, I think all of a sudden I'm doing it wrong. Well, it would look something down here. Bottom line is it wouldn't be on top of itself. So it can't be about the origin. It has to be choice D, which it is. The other way that you can know it's by choice D is, do you see where these lines intersect? At 2, 2. That's how you know you can rotate it there. And it makes sense. If I was holding up a piece of paper, I could put my pen on that point and turn it. And that would show me how many degrees I had to turn the paper. So that's just how we do that problem. Okay, next one. Oh, sugar shoots. Well, that's fine. We're going on to constructions anyway. So here comes our constructions. You do need to know these things about constructions, okay? But if you only had time to memorize 2 constructions. I could be wrong, but I would suspect the 2 constructions that you need to memorize are over here. Angle bisector. Okay. And when it comes to angle bisector, an angle bisector divides the original angle in half. And then each mini angle, each little teeny weeny piece is equal to half of the larger angle, which should make sense. The other one I want you to remember is perpendicular bisector. Now, I haven't seen the test. I don't know if it's on it. Even if I did know, I couldn't tell you, but I truly haven't seen it. The issue is that I have seen multiple EOC questions that reference either angle bisector or perpendicular bisector. So if there's a construction question, I bet it might be one of those 2 things. Okay, so let's go back here and take a look. Again, if you didn't get this paper today, like at the after school review, I have copies for you in my classroom. If I see you tomorrow, you can pick it up. Otherwise, you can pick it up outside my door. Here it says, which illustration shows the correct construction? Dude, look at the picture. What did I tell you it looked like? In order for it to be an angle bisector, it tells you literally angle bisector right here. We need to have the arch. See this little arch here? So we can't be this one because that one doesn't have the little arch. This one, and then it also has to have these 2 little crossy hair things. Well, this has the little crossy hair things, but there's no arch. So it's not that one. This one has an arch, but no crossy hair things. So this is it. Okay. As a side note, basically you have your angle. Okay. So if I was drawing it, here's my angle. I am going to draw an arc from this point. Here's my arc from this point. Then I put my compass here and I'm going to draw an arc this way, put my compass here, draw an arc this way. That's my intersection. And I draw my line. That's how you create an angle bisector. Really, you just need to know about an angle bisector. Okay. And let me show you where the other ones are. Okay. I'm saying okay a lot. Oh my goodness. Here we go. Based on the construction below, which statement must be true? Dude, hold up your paper to the screen, draw the shape and color things in to help you do it correctly. Or you could always draw it on paper, but give me a break. Like that's going to help you the most. Let's go work backwards. Here's CBD. It says CBD is 1/2 ABD. So here's CBD. So I'm going to color that CBD in. Okay, we did that. And then it says half of ABD. So here's ABD. Half of it would look like this. Is that the same amount? Nope. So it's not going to be 3. Then you're going to do this again and you're going to be like, all right, ABD, here's ABD. That equals ABC. Well, ABC is this whole thing. So does the blue equal the whole pink? Nope. So it's not 3. Literally do process of elimination like this, please. Next, I have ABD. Here's my ABD. Equals my CBD. Here's my, oh, look at that. They equal each other. So I know it's going to be this one. Just for kicks, our other one says ABD, which is the blue, is half of CBD, which we know that it's not half. So that's why it's not that one. Trash can. Good. Okay, here comes our next set. Okay. This one, I don't want us to do because I don't think you're going to see it. Here's the next one. Which diagram shows the construction of a perpendicular bisector? Holy moly. Did I just tell you that this was something important to know about? Which picture matches? Well, we know in order for us to do the perpendicular bisector, you're going to put your compass here and draw an arch. You're going to put your compass on the other one and draw an arch. And wherever they intersect, you're going to draw the line. So it can't be this one because there's no arches on the top and bottom of the line. It can't be this one because they did it exactly equidistant. They didn't do the overlap, and you have to do the constructions with the overlap. And it can't be this one because I don't even know what they did. So that's why it's number 1. All right, so we have just covered, oh no, we haven't. Let's look real quick on number 2. Oh, that looks like a really angry person, doesn't it? Eraser. Okay, looking at number 2, which geometric principle is used to justify the construction below? A line perpendicular to 1. Well, dude, I don't see anything that's perpendicular, so we're going to cross out 1. 2 lines are perpendicular. Dude, no perpendicular. Cross out number 2. When 2 lines are intersected by a transversal, that's a whole lot of information. Look at the same thing to start number 4. When 2 lines are intersected by a transversal. Because both of these say the same thing, we're going to cross off what's the same. because we don't care about that. If they're in both of them, that doesn't tell us anything that's helpful. Then it says alternate interior angles. And this says corresponding angles. And then are congruent, the lines are parallel. So basically speaking, we're looking at, are those angles alternate interior or are they corresponding? Well, hopefully you realize they are corresponding. If it was alternate interior, the blue angles, for example, would be alternate interior. They're inside the parallel lines and opposite sides of the transversal. So that would be there. Okay, congratulations, everyone. Give yourself a round of applause. You have just done Unit 1. Yay! Let's go to Unit 2. Okay, so trash can. Let's lift this up. So now we're going to start on focus on this next section, similarity. Okay, a couple of notes that I need you to know. We're not going to do that question. First things first, similarity. We want to make sure the lines match, and I called it roof to roof. And we're going to use this problem to help us. I also put the picture in the diagram right here. So we're talking about this. Okay, we want to make sure the lines match. For our scale factor, we're going to do new divided by old. New divided by old. Anytime you do scale factor, you do new divided by old. If you're doing a proportion, though, proportion, that's going to be new over old or old over new. It doesn't matter. But you just got to make sure you keep it the same. The other thing to remember is sides proportional, angles the same. So let's take a look. I'm going to work backwards on this question. Here it tells me that AB and AB prime match up. Okay, that makes sense. They're both the same side of the house. Here it tells me DF, D prime, F prime, matches to BC. Well, this is the roof of the house like this, and this is the side of the house like this. There's two different parts of the house. So because of it, it cannot be choice D. Okay, if you look at choice C, it's the same letterings, but in different order. So it can't be choice C. So now we're looking at it either being A or B. So the formula I told you is either new over old or old over new. It just has to be the same no matter what when you're coming up with the proportion. If it's scale factor, it's always new over old. So if we look here, AB is our old shape and A prime, B prime is our new shape. So here's our old shape, here's our new shape. B prime, C prime is our new shape, and BC is our old shape. Down here we have AB is our old, A prime, B prime is our new, BC is our old, B prime, C prime is our new. So our answer is choice B. And this is how I've been explaining it to you guys. I want you, whenever you see similarity, to think of dating someone. If you are dating someone, you are on, because you're dating them. Woohoo, your guys are on fire. Good job. Now, if you're dating someone, but you're not going on dates, are you really dating someone? But down here, if you're going on dates, old over new, okay, and you guys are on fire, yay, you're dating, and you're going on dates, that makes sense because you're on fire and you're dating. Okay. The issue is if you're on fire and you're not dating, you're really not on fire. So that's why this doesn't make sense. You got to keep it the same. Old, new, old, new. You also could do new, old, as long as it's the same. It has to be the same on both sides. Not dating someone, not going on dates. That makes sense. You guys are on, you're dating, you're going on dates. So no, on. That's the end of that question. I'm done belaboring that. Okay, next one. I did talk to you about that one already. So let's move on to here. Okay, I told you guys about this. And your main thing that I asked you to remember, one of your core things to remember is similarity. Make sure the lines match and that sides proportional angles are the same. Here it has a dilation. So because it's a dilation, we know that it's similar. Okay. But the issue is just because it's similar, we mean this because look at, they give us angles. Here it says 50, sides similar, sides proportional rather, angles same. So if this is 50, this has to be 50. Ginger, don't go over there. No. So I saw some ants and I sprayed Raid and I've been trying to keep her away. I mean, it was an hour and a half ago, but she's trying to lick the floor. Go lay down. Go lay down. Good girl. Go lay down. You're okay. Good girl. Go lay down. You need to stop that. Go lay down. Okay. I apologize for that. That's funny, Jahir. Considering weren't you the one that said you were married the other day? Come on, come up here and lay down. Excuse me 1 second. Lay down. Come on. Up, up, up. Come lay down. There you go. Okay, I apologize for that, but I just don't want her licking, ant poison. Here we go. My apologies. Honestly, I'm not going to edit that out. Let's keep going. All right, B is 100. Here is 100. Again, sides proportional, angle same. Good girl. Sides proportional, angle same. So now we look at what's Z going to be. Well, we know that a triangle has 180 degrees. If this equals 150 degrees, then how many degrees are left? 30. And if the sides are proportional and the angles are the same, that also equals 30. Let's cross our fingers we get a question like that. Wouldn't that be a nice question on the test? Sides proportional, angles same. See, the reason why it's hard is they trick you. They say, oh, let me tell you 2/3 to confuse you. Don't pay attention to it. We only pay attention to it if we're talking about sides. We don't pay attention to it if we're talking about angles. Okay? That's why you put it on the chat box the other day, Jahir. Come on. Okay, here we go. All this is out. Now, this next set of information, the EOC said was important. I'm going to ignore what they said and bring your attention over to what I say. So basically what I did is this. I said, you know what? Let's try to break this out. When you have vertical angles, you will almost always see vertical angles if it mentions congruent and you see a bow tie. So see down here, I have my bow tie. Well, I'm proving congruent triangles and I see a bow tie. So I know I'm going to use vertical angles. Specifically, you're going to use vertical angles for these two parts right there. Okay. Next, actually, you know what? Let's trash this and let me blow this up. Let's really focus on this slide. Open up, open up. You can do it. You can do it. Okay, perfect. Okay, so vertical angles are congruent. You're going to get the bow tie. So here's our bow tie. These two blue angles are our congruent. Okay. So here we go. Here we go. Okay. Next. Sammy, I agree with you. The next thing that we have here is alternate interior. If they mention parallel and you're proving something congruent, more often than not, you're going to be using alternate interior. And this is exactly what's happening. Here's our parallel lines. This right here and this right here would be alternate interior angles. Okay. So remember that the angles have to touch the parallel line. So it wouldn't be this one and this one because it doesn't touch the parallel line. Okay. Corresponding angles, you're going to see whenever you see similarity. So here's our corresponding angles. The question that you're going to see coming up on the EOC is like this, and you would use corresponding angles here and here to prove those two triangles are similar. Perpendicular bisectors, things to know is that they form right angles and they divide the segment. So you might see a shape like this, and this is the same, and then you get your right angles. Midpoint divides a line into congruent segments. This was actually also a midpoint formula so that you would also find those sides, but you'd have to see the word midpoint. Isosceles triangle, I'm 50-50 that you might see that. Basically, whenever you have your isosceles triangle, the opposite angles are congruent, so are the opposing sides. The mid segment, we did a whole lot of, but I haven't seen a whole lot here. Mid segment is basically when you took the middles and you went like this and it broke it up into equal parts. I can't think of one EOC mid segment question I saw. That doesn't mean it doesn't exist, but I just can't think of one. Reflexive means it's congruent unto itself. In this case, this is my reflexive, because in order to solve this problem, I need that orange piece for this whole DF line, and I need that same orange piece for this HJ line. Excuse me. So this overlap would be the reflexive property. Okay. Then when we talk about what are the types of congruent, you have side, angle, side, and angle, side, angle, I want to talk about. Now, I've told you you need to make a sandwich. This is my sandwich story. Here we have a piece of bread, and here we have a piece of bread, and inside we have our, I still like to say fluffernutter, but peanut butter and jelly. Here you have a piece of bread. Here you have a piece of bread. Here's your peanut butter and jelly. So if it was to be side angle side, you would have to have two sides, the bread and the inside jelly. If it was angle side angle, you would have to have two angles and the inside jelly. If you don't have side or angle side angle. You need to make sure that if you have one of those two things, that your opposite one, whether it's this angle inside of a side angle side or the side inside of an angle side angle, fits literally touching the pieces of bread. You do have angle side angle, hypotenuse leg, and side side side. Let's trash the screen. Come on, computer, Dora. Oh, that's why. All right, let's go back to the EOC questions. Move you over here. Thank you very much. Epic Review. You've been so kind. Okay. So these are other things that they want you to know. They do want you to know this whole idea about how do you get a good girl, Ginger. But how do you get a quadrilateral? How do you get a rectangle? You do need to know that information. It is on here underneath parallel facts. So parallelogram has opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. If the diagonals bisect each other, you know it's a rectangle. If the diagonals are congruent, it's also a rectangle. Now, there is more information that you could know about if they are perpendicular, then it's a rhombus. But I didn't see any EOC questions with it, so I didn't put it on the very important sheet. In terms of proofs, here's that parallelogram. I told you, remember, whenever you see something and it tells you that the sides are parallel and you're proving congruent, more often than not, you're going to be using alternate interior angles. In this case, we did these two angles here. Down here, we see a bow tie. I told you, whenever you are doing something that has a bow tie, you are almost always going to do vertical angles. Now, this one has the vertical angles, and it also mentions parallel and congruent, so I knew I was also doing alternate interior angles with this angle and this angle here. I'm sorry, I need to go back to using my finger. Let's do that one more time. On this slide here, it says parallel, so because it says parallel, I know I'm going to be doing A, B, and D, E. Here's A, B, and D, E. So I know I can do B and D because of alternate interior angles. Remember, I told you over here that if it's congruent parallel, you are almost always going to use alternate interior angles. Then we also see that it makes a bow tie. And I also told you that if it's a bow tie, it's congruent using vertical angles. And so we have both those types of angles right in here. Okay, here we have a midpoint. They could have told you it was a perpendicular bisector. They didn't, but they could have told you that. Pretty much you're just going to have to figure it out. Midpoint just divides it in half. This is the reflexive property with this line, which again is down here. The side is congruent to itself. Looking down here, it mentions midpoint again. The only other thing I'd like to say about midpoint is make sure that you pay attention to the sides. So this says I is the midpoint of XM. So I'm going to draw XM, and then that's how I get my points. If you said AI and OI here, it would be wrong. So just make sure that you follow the proof and what makes sense of the step ahead of it. Again, this is a bow tie. So what do I get? Vertical angles are congruent. Okay, here's the image I had drawn in terms of similarity. We don't have to really look at all of this kind of stuff because I told you, guaranteed, if you see similarity, what we do, similarity, where is it? Right here, angle, angle, similarity. And you see parallel lines, you are going to get boom, boom, corresponding angles. So let's see. Next one. Okay, we have this, and it tells us that it was translated. This shouldn't have been in this one. It should have been in Unit 1. But here it was translated, and then it was rotated. If we look up here, translated and rotated are rigid motion, so it's congruent and similar. So it's choice A. If it got bigger or smaller, then it would be similar only. But remember, you will never have a congruent only. Congruent only does not exist. If you have congruent, you have to have similar. It's just the facts. Okay, let's take a look here. Consider it these, which can be used. Well, let's draw it. We have an angle. We have another angle. And we have a side. So we have two angles and a side. Well, it can't be choice A because choice A says we need three sides. We do have two angles and a side for B, so we'll leave it. C says two sides and an angle. We don't have two sides. We only have one side per triangle. So, and then we're left with here. So this is where the sandwich comes in. Remember, you have to make a sandwich in order for it to be side, or angle, side, angle. In order for it to be a sandwich, we would need the side to be this blue line. It's not the blue line. So because of that, we did not make the sandwich correctly. So it cannot be this one. It has to be angle, angle, side. Oh, why do I keep doing that? Okay, here's this next one. I already went over it. You need to know the choice B. Okay, we need to know choice B because if we knew HF, we have the reflexive property. So if we knew DH, we could get this whole side. And if we knew FJ, we could get this whole side. That's why we need B. Okay. Next. Here we have that same picture from before. How do we prove it? Please don't just put like hypotenuse like because you see right angles. So let's look at what they give us. They tell us that AD and BD have the same measure. They tell us that CD is CD. Now, you know what kids do right here? They're like, oh, side, side, side. We don't know anything about AC or CB. You can't do side, side, side yet. So we're going to keep reading. And then it tells you ADC and BDC. So, well, here's ADC. Here's this angle. And here's BDC. So what do we have? We have two sides and we have one angle. So it can't be the first one because there's only one angle. It can't be the second one because there's only one angle. So now we're between side, angle, side, and side, side, side. Well, we only have two sides, so it can't be that one. It's got to be side, angle, side. But we do have a sandwich, so that makes sense. We have our angle. Our blue angle is between two pieces of bread, our two pink lines. So that works, and we're good to go. Okay, here's another one, our last proof one. Woohoo! What do we do here? Most of you have seen this question several times. It's one of my go-tos. This is a whole lot of reading. And a lot of kids say, man, I'm done, Miss Ear. I can't even do this question. It's so much work. Don't be like other kids. Have a growth mindset. First, cross off things that make no sense. Definition of right angles. What right angle do you see in the picture? None. So we're not going to have it be C. So we're going to cross out C. Sorry, C. Nice to know you. Angle congruence postulate. I can't remember of an angle congruence postulate. I mean, I'm sure it exists, but I don't know what it is. And it's not something we use very frequently. So we're going to take off D. We have to use reflexive property, but reflexive property only happens when a side is congruent to itself. You technically could get an angle congruent to itself. Like if you were proving similar triangles, you could possibly do it. So again, that doesn't make sense. So process of elimination at CPCTC. The other thing you can see is look at the line in front of it. It's congruent. So corresponding parts of congruent triangles are congruent. So you got to have congruent triangles first, and then you can do CPCTC. All right, lovies. Yay. We got through the unit 2, and that was like one of the harder ones. So congratulations. We're going to keep on moving on. All right, let's take a look at right triangles. The main things to know for right triangles are this. You do need to know Pythagorean theorem. You don't have to memorize it, but you know how to use it. Pythagorean theorem is on the formula sheet. The main thing to know is the hypotenuse is always opposite the right angle. That's always going to be your biggest side. Okay. Next, we're going to see things like this. For trig, theta is always the angle that you're talking about. Always. So if it says sine B, theta is B. If it says 37 degrees, theta is 37 degrees. Whatever they show you, that's what you're going to be using as theta. If you need to determine the sides, you are going to use trig ratio. If you need to determine the angles, you are going to use the inverse button, which means you're going to hit second and then either cosine, sine, or tangent. Here's the good news. They give you this on the formula sheet. Okay. Actually, it looks like this, but they give you the information. You don't have to memorize the trig identities. What you do need to do is know how to use them, but you don't have to memorize them. let's take a look at how to use them. Okay. Here we go. We've got Ricardo, who's standing 75 feet away from the base of a building. The angle of elevation from the ground where Ricardo is standing to the top of the building is 32 degrees. What is X, the height of the building, to the nearest tenth of a foot? So we've got, here's our theta, because theta is the angle we're talking about. Okay. So then we're looking at, let's label these. What's opposite? What's hypotenuse? What's adjacent? Here's my right angle, so I know this has to be my hypotenuse. Because this is my hypotenuse, I know that this is my opposite side. If this is my opposite, I know that this is the adjacent side. I notice the adjacent because it touches the angle. It's the adjacent because it touches the angle. Adjacent touches the angle. Okay. So now I know I have opposite over adjacent. So I'm looking opposite. Ooh. Yeah, opposite over adjacent. So it can't be opposite over hypotenuse because I don't have the hypotenuse. It can't be adjacent over hypotenuse because I don't have the hypotenuse. So it's got to be tan theta. So I know tan theta is the one I'm going to be using. So what do I have? Here's tan of 32 degrees. So theta is the angle I'm talking about. So I've got tan 32 equals the opposite, which is X, over the adjacent, which is 75. So I've got 0.6249 equals X over 75. Then all you do is cross multiply and you're going to get your answer, which I was going to skip, but I can do that for you. 0.6249 times 75, 46.85. And because it says it wants to the nearest tenth, we're going to round it to 46.9. And that's it. It does seem like a lot, but if you're just methodical, you'll get it. Here we have an airplane that's descending at an angle of 3 degrees. Using alternate interior angles, we know that that's 3 degrees there. We want to know this. Well, here's our right angle. So we know that this is our hypotenuse. We know that this is our opposite from our angle that we're talking about. Here's our angle. And we know that this is adjacent. So we have opposite and hypotenuse. Opposite and hypotenuse is sine. So we're going to use sine of 3 degrees equals, here we go, sine of 3 degrees equals our opposite, which is 5,900, divided by our hypotenuse, which is X. So basically, you're going to plug that in. I missed a 0. Okay. Multiply both sides by X. And then when you do the division, you get 112,810. Okay. 0.7 feet till he hits the ground, which makes sense. Okay. If he's 59 and he's going down, that's how it works. Okay. Here's another one. Let's do this one. I do prefer that you watch the whole trig video, but we will do a couple more. What's the best approximation for sine the measure of C? Basically speaking, here's this. We know that if we have 5 over 12, which would be sine, we're looking, okay, well, what's 5 divided by 12? So all you're going to do is use the inverse function. Well, you could just actually do 5 divided by 12. That's going to be 0.416. And we're trying to get to 0.923. So now if I have cos, my cos is 12 over 13. So if I type in 12 divided by 13, okay, that's going to give me, oops, I didn't hit equal sign, 0.9230. Oh, which is exactly what we're looking for. So we know our answer is cos. You could do it another way. You could do inverse, but we're not going to get into that. I say use it as a multiple choice and just figure it out that way. I'm going to skip those 2 trig problems. Let's look at these 2. A 12-foot ladder is leaning against, I feel like using green, 75-degree angle. Which equation? We want questions like this because you don't have to do any math. You just have to know how to set it up. My Fitbit is telling me to move. Okay, so here's our 75 degrees. Here's our angle we're talking about. Here's our right angle. Because this is the right angle, we know that this is our hypotenuse. Because this is the angle we're talking about, we know this is our opposite. So we have opposite and hypotenuse. So opposite hypotenuse, if you look over here, is sine. So surprise, I would have guessed it was sine anyway, because look at it. they give you 2 sine 75s. So remember, it's opposite over hypotenuse. Our opposite side is x. Our hypotenuse is 12. And literally, that's the whole problem. Let's pray we get one of those. Fingers crossed. That'd be so nice. Okay, here comes our next one. Okay, now we have a hot air balloon. It's going down at 54 degrees using alternate interior angles. You know that that's 54 degrees. We're trying to determine D, given that information. Well, we know that we've got here's our right angle, that this is the hypotenuse, and we know you have this is the opposite. So you're looking at sine of 54 equals your opposite, 1200, over your hypotenuse, which is D. Choice B. Done. All right. Yay. We just went through unit 3. Congratulations. You guys are on unit 4. Woohoo. Thank you for sticking with me. We're on slide 64. Okay. These things you need to know. Now I'm over here on our review sheet. You do need to know these angle things, okay? You need to know what a central angle is. You need to remember that arc to angle we divide by 2 and angle to arc we multiply by 2. You need to know that if it's internal, you add first because it makes an x, so that looks internal. That if it's external, you do the subtraction. Those are things that you need to remember to do. You need to know those things, okay? You're not going to get that on the formula sheet. Other things that you do need to know, which I have over here, is you're going to have to know that tangents are perpendicular and form 90-degree angles. If you have something that's on the semicircle on the diameter, okay, that this forms 90 degrees, okay? If you have something that's inscribed, so you have some points that are on the circle and it's a quadrilateral, those opposite angles measure 180 degrees. Here also it mentions the perpendicular piece that it touches in exactly one space. And I also have that these opposite sides are congruent. Those are core principles to know for circles. So let's go here. You probably should know the circle pictures, but you know, I do have over here that you also do need to know the stuff about segment relationships. Basically, part over times part equals part times part. Remember here we have ow, that if you see something that's outside the circle, you're like, ow, outside times whole equals outside times whole. So those are these things. Again, if it's on this sheet that I made for you, you really need to know it. If you know those things on the sheet, you will have a higher percentage of doing well. Arc length, remember we talked about it being 2 times pi times the radius times the angle you're talking about divided by 360. Area of a sector, I have no idea. Oh, the top part is if they're doing it for radians. I've pretty much only taught you the degree method. So pi r squared times the angle you're talking about divided by 360. Okay, let's take a look at some questions. Hi, Ginger. Gonna go lay down. Okay, here we have PQ is 70. Here's my PQ at 70. Because this is a central angle, I know it's a central angle because the vertex is at the center, that this is also 70. But I know that this is an inscribed angle, and I know that arc to angle I divide by 2, so this is 35. So you could say it's half the measure. Okay, something along those lines. Okay, you can go on the couch, honey. It's okay. Here we have another one. We have the circle. It's tangent. Okay, because it's tangent, we know that these opposing sides are the same. Hi, come on up here. I don't want you looking at anything. Come on up. Go lay down. Here we have 48 degrees. Because this is 48 degrees, we know that, hold on, get over here. Ginger needs to go lay down. 48, this is 96. If that's 96, this is a central angle. So we know that this is 96. And then that means that this angle out here, this blue angle, plus this 96 has to equal 180 degrees. Ginger, don't, excuse me, please. Come over here. Good girl. Nope. Up, up, up. Come on up. Good girl. Come on up. Come on, go lay down. Go to bed. Come on. Go to bed. So we know that these two have to equal. So we have circle angle plus 96 equals 180. 180 minus 96, I think it's 84. Yeah. So we know that angle has to be 84 degrees. Okay. Well, again, we know that because opposite sides equal 360. Ginger, stop that. Hey, stop that. Okay, moving on. Okay, we have C is the one that's dilated. Ginger, stop that. Okay, C is the one that's dilated. Remember, I talked to you about it on the front page that whenever you have that, the ratio of the diameter to the circumference is the same. So that's another example of that. Please don't do that. Stop. Moving down here, you will see a question like this just because it's one of those quintessential questions. Here you have 180 degrees. Okay, a straight line's 180. We know that it's 180 degrees. If this is 120, that means there's 60 degrees left here. Then we're going to look for ABC. This means it's an inscribed angle. 60 divided by 2 equals 30. And that's how we get 30 degrees right here. Okay. Here, I'm not going to do this problem. You're just going to have to use your formula sheet. 2 times pi times the radius times theta divided by 360. Okay. Area of a sector. Same thing. The formula sheet is pi r squared theta divided by 360. The trick is this is the shaded part. So you're going to take your 360, you're going to subtract your 75 to get your arc. 360 minus 75 means the arc I'm talking about is 285 degrees. Now that I have that, that's what I would put in here to solve the problem. Again, this problem I already did. It's on the circles video. Okay, this one's on the circles video. I'm not going to waste time. Yay! Congratulations. You just went through Unit 4. Okay, Unit 5 modeling. This one has a bunch of equations available for you on the formula sheet. You'll use it here. You'll also use perimeter and distance formula if you don't use my math hack. I'm going to go super fast through these. I'm not even going to do all the questions because I made this really long video on modeling already. And I made 90 of you watch it today. So I'm not going to spend a whole lot of time on this section. Here, basically, all we're going to do is this. Notice how that is the side of the cone. It's not the height. Here's the height. So if we know this whole thing is 16, we know this piece is 8. So we're going to do a squared plus b squared equals c squared to get our missing side. That's going to give us our x. Once we have that, then we're going to embed it into the cone problem. Again, I want to go fast because I'd rather you watch all the stuff on volume and all the stuff on probability. So I'm rushing through so that you have time tonight to please watch volume and modeling and please watch probability, because me covering just 3 or 4 questions isn't going to really help you. I do want to jump over here though to show you this. Trash. Come on, come over here. Okay. Here, when we do volume and modeling, these are the things that I wanted you to remember. Anytime you have Cavalieri's principle, if you see the words parallel lines, planes, area, and cross section, you really need to think Cavalieri's principle, which means the volumes are the same. For circles, anytime that you go from the formula to the center or vice versa, you're going to switch the signs. You'll see examples tonight. When you have the formula and you're going to the radius, you take the square root. When you have the radius and you're going to the formula, you square it. Down here, if you have the radius, you're going to use the center as the endpoint and use distance formula, okay, to find that distance to get the radius. And then this is how you do circles. For slope, you should know y equals mx plus b. You should know that parallel is the same slope and perpendicular is opposite reciprocal. Okay, those are all things that you really should have a clue about. Hold on, let me just see where we are on something. Okay. Trash can. So I'm going to keep on keeping on real quick. So here, volume, you just need to watch these modeling ones because I'm not going to spend time continuously going over it. There's plenty of examples and we did them in class. So this is, look at the playlist. Cross sections, you will probably see at least one cross section problem. Here, it mentions a square base. So you're going to see what makes sense here. Clearly, in this case, it would be a rectangle because it's parallel. Here's the Cavalieri's principle. And what I said on the sheet is if you see Cavalieri's principle, basically you're going to have equal volumes and the words you're going to see are parallel, cross-section, and areas. If you see parallel, cross-section, area in some order, you know you're going to have Cavalieri's principle. Guaranteed. Cavalieri's principle. Okay. Where do I want to jump to? Okay, so here's an example from the formula sheet of how you would do it. Okay, then if I go here, again, let's look at these choices. Basically, we have these two center things of washers. Okay, it says they have different volumes because they have different radii. Nope, that's not what I taught you. Different volumes and different surface areas. Nope, we never talk surface areas. Different, they have the same volume because the washers has the same height. I did talk to you about height, but remember you need cross-section, area, and parallel or height. Let's look at choice D. Have the same volume. Why? Oh, cross-section, area, parallel. Holy moly, Miss Erig actually knows what she's talking about. Okay, density, this one. Again, I'm not going to really go spend time over these because I go over them at length. The main thing I need you to think about is the idea of per. If you see per, it means divide. So in this case, it says 6,888 per 7.267. That's literally all you're doing is dividing. Anytime you see per, good girl, thank you. Okay, that means dividing. Here's my notes on circles that we talked about. Here's the hack. Okay, let's take a look at a circles problem. Anytime we go from center to the formula, we're going to switch the signs. So I'm going to set it up. How do I set it up? You set it up using what's on the formula sheet. Okay. Whew, I jumped. You probably saw me jump. Here's +4, so this is going to be -4. Here's +5, so this is going to be -5. Here's 2, so 2 squared makes this 4. That's it. That's the whole equation. Let's hope we get a question like that. If you're going to screw it up, you're going to forget to switch the signs. Okay, this one I am going to model. This one we're going to go backwards, okay, and see which one makes sense. First things first, we're going to do x plus 2 squared because this is negative, plus y minus 3 squared because this is positive, and that equals the radius squared. 3 times 3 is 9. If you didn't know it, you could have looked it up. Then the long way, I'm going to show you the long way. Here I've got x plus 2 times x plus 2. So I could do distribution x times x is x squared plus 4x plus 4. Here, I forgot the squared. This is going to be y squared minus 6y plus 9 equals 9. When I arrange it into pretty order, I get x squared plus y squared. So right away, we can eliminate b and d because those have numbers in front of it. Then I've got plus 4x minus 6y. Well, both of these have x squared, y squared plus 4x minus 6y. When I bring these together, 4 plus 9 is 13 equals 9. Here's the issue. All of these choices end in 0, so I have to get rid of this 9. The opposite of adding 9 is subtracting 9. So that gives me 4 and all this other kind of stuff. So it's going to be choice C. Okay. Hold on. I just saw that, Sammy. Me too. You guys are welcomed. You know what? I'm actually really proud of you. I was just thinking, man, I should probably go so I can see the comments again. I'm actually really proud of you guys because you guys have also sacrificed a lot. So I am going faster through here, but my hope is that you guys take the time to look at the stuff on your own. And instead of doing everything that I show you, you do the things that make the most sense for you. So the questions, the videos I really want you guys to see are probability, because most of probability we did before break, and I haven't really reviewed it since break, and really going deeper into most of these. Okay. All right, let's keep going. Thank you for your patience with Ginger. She finally looks like she's settled down. Okay, here we go. We have this here. Again, I'm going to model how we do this problem. I told you that first you're going to group the x's. So we've got x squared minus 10x plus leave a space. Then we're going to group the y's. But look, there's no other y term. So I'm going to put 0y and then leave a space. And then I've got my negative 11. So if I go down, I've got divide by 2. That's going to give me negative 5. Then here, when I divide 0 by 2, that's going to give me 0. The opposite of negative 5 is positive 5. The opposite of 0 is 0. So your choice is choice A. Okay. Not going to talk about slope. You should know slope. Jahir, you and I are going to have a separate conversation based on our emails. Okay, here we have our directed line segment. Okay, for directed line segment, I don't really want to do all of this because I do go over in the modeling video. Your takeaway that I really want you to know is that when you have the word ratio, your first number is A and your second number is B. So for directed line segment, this is the formula, for example. Okay, so I would have here B would be 3. My x1, here's my first point, is negative 1. My A is 1. My x2 is 7. And then I divide by adding those up. So I got negative 3 plus 7 divided by 4. 4 divided by 4 is 1. So I know my first coordinate happens at 1. And then you would do the same thing for the y term. Okay, I know I'm pushing you because, again, I just want to go through it. Area of a rectangle. The takeaways I want you to remember here is because it wants to find area, you need to use the distance formula to find the sides. And then you're going to have to just multiply base times height. So I'm not going to do the distance formula 1,000 times, but here we go. We have A, B, C, D. Remember, we write it in a circle, A to B, C, D. Okay. All you need to do is find one length. So you could use the distance formula for AB. You can use the distance formula for BC, and then you would multiply these two numbers together, and then you're done. Granted, on a piece of graph paper, it'd be slanted, and that's okay. Basically, this is just to help you to know which sides you need to do. Okay. Here, you're going to end up looking at your sheet that I gave you to know what do you need to know. You either know it or you don't know it. This one we've already done before. Let's take a look here so we can just wrap up modeling. Okay, here it has an equation of a line as y equals negative 1/2 x minus 1. It wants to know something perpendicular. First things first, we take that negative 1/2 x because y equals mx plus b. And then we take out the x because I shouldn't have written it. And then we're going to do the opposite, reciprocal. So that's going to give me positive 2 because the opposite of negative is positive. And then when I flip this fraction, I get 2. So right away, I'm crossing out A and B. The reason why I'm crossing out A and B is because those are actually parallel lines. Now it says it needs to go through this point, negative 4, 0. Two ways that you can do it. First, you can plot the point, negative 4, 0, right here. And then you can graph these lines. So this says negative 2. So here's negative 2, and it says go up to over 1. So if I go up to over 1, this is where my line's going to be. Well, clearly that line does not go through this point. So we could cross that out. If we go over here and graph this line, here's positive 8. If I go up to over 1, it looks like this. If I go down to over 1, it looks like this. And what do you know? It crosses through negative 4, 0. So I would probably just graph it and see what makes the most sense. If you didn't want to graph it, the way I showed you in the other videos is you take your new slope, put it into y equals mx plus b, and then you take these points and plug it in. 0 becomes the y, negative 4 becomes the x, plus b, 0 equals negative 8 plus b, solving for b, add 8 to both sides, and then this is where you get your 8. You can do it either way. All right, congratulations. You all just finished units 5 and 6. Let's go on to the next one. Probability. All right, I really am not going to do a whole lot with probability because I did a whole video yesterday for 45 minutes going over it. Here's the highlights that you need to make sure that you know. Whenever you have complement, basically see how we have this dark blue circle and this light blue. If it's not in the circle, then it's not going to be it. So if it's like this is, since we like to talk about marriage and engagement rings so much, this is like this circle is yes, you're engaged. This circle is no, you're not engaged. Okay. Here, it's like you can't be engaged and married at the same time. It just doesn't happen. Mutually exclusive. Okay. Here for union is all my stuff from my house gets together with all the stuff from my partner's house, and we count everything. Down here would be like our kids. Intersection is what you have in common, what you have the same. And then if something is independent, when you multiply the probabilities, it's the same thing as P intersection A, B. Here's this problem here. It says V represents a set of license plates beginning with a vowel. Okay. O represents an odd number. We did these before break. Which license plate is V and not O? So we want to say, well, we want it to be a vowel. So it can be A because here's E. It can be C because here's A. It can't be B because M is not a vowel. It can't be D because P is not a vowel. Now we want a number that's not odd. Well, a number that's not odd is even. So we want an even number. So it's got to be choice A because 9 is odd and we don't like odd numbers. So we're deleting it. Done. Okay. Down here, look at this. This is so important. Do you see how this problem, it says blah, 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 be independent? Let me do that again so you catch it. It's very subtle. Blah, 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 blah. Be independent. Then look at what says on your formula sheet. Multiplication rule for independent events. See how this says independent? See how this says independent? I bet it's probably important. And I would use my formula sheet. All this says is the probability of A and B, which is all these numbers here, equals multiplying A times B. So all you're going to do is you're going to multiply this times this. This would be 0.625. This times this would give you 0.32. So that doesn't equal those numbers. This gives you something that I don't remember. So it's going to be choice D. Okay. Really, probability, see if it matches up with one of the formulas. Let's take another look. Assume that the following events are, what's independent? So I'm going to look at that thing, multiply these two numbers together, and that's going to be your answer. It's literally that simple. Okay. Now, as a side note, of course, not every single probability problem will look exactly like this, but it does help. 0.33 is what you end up getting. Right here, 0.33. Okay. Here, this one I am going to demonstrate because I did a crappy job of it after school, and I want to make sure you get it. I do a good job of it after school in the video. Or in the video I did yesterday. Bianca spins 2 spinners that have 4 equal sections numbered 1 through 4. Okay, so we know where numbers are 1, 2, 3, 4, and 1, 2, 3, 4. If she spends at least 4 on one spin, what's the probability the sums is an odd number? The only way to do this problem is to take your time and come up with the pairs. But if you can take the time and do the pairs, you will most likely get it right. So I say, please go ahead and do it. So I could get a 1 on the first spin. And then on my second spin, I could get a 1, 2, 3, or 4. I could get a 2 on my first spin, and my second spin could be a 1, 2, 3, or 4. I could get a 3 on my first spin, and my second spin could be a 1, 2, 3, or 4. I could get a 4 on my first spin, and on my second spin, I could get a 1, 2, 3, or 4. So now we're going to look at which one of these satisfies the condition of spins at least a 4. So I could get it here. Here I spun a 4. Here I spun a 4. These are all the times I spun a 4. So if she spins a 4 at least on one spin. So if I spun a 2, 3, it doesn't count because I have to spin a 4. So all these other numbers, it doesn't matter because I didn't spin a 4. What's the probability that the sum is an odd number? So now I'm going to come over and say, okay, what of these numbers are odd? 1 plus 4 is 5. So that's odd. 2 plus 4 is 6. Nope. 3 plus 4 is 7. Odd. 4 plus 4 is 8. Nope. 7. Okay. So how many yellow things do I have altogether? 1, 2, 3, 4, 5, 6, 7 in the denominator. How many circles? 1, 2, 3, 4. 4 sevens. Choice C. I almost had a heart attack. I'm like, man, did I do that problem wrong? Please take the time and do it. That's all I got to say. It'll be worth it to you. Here, take a look here. Each letter of the alphabet is on separate cards in red ink. The cards are placed in a container. Each letter of the alphabet is also written in black ink. So we know how many letters are there. There's 26 letters in the alphabet. So we know that we've got 26 red and we've got 26 blue. Or I'm sorry, why did I say blue? Black. Okay. The cards are placed in a container. What's the probability that a randomly selected card has a letter written on it in black ink or, so I'm going to use addition, A or Z? Oh, look at, here's the word or. Okay. Thank you for telling me. Can you please hold on? You're okay. See, this is what I get to deal with. There's my messy